All right, Algebra 2, we are finishing up the practice test. I apologize for the mishap yesterday, but we're going to get through the practice test here. So, again, a lot of proportions for the first couple days. We talked about probability, best fit line, and a little bit of reading the graph. So, in this case, let's look at number 9. It says, which of the following equations relates y to x? So we're really trying to figure out which one of these would be y equals the equation that fits the table. So first, what you want to kind of look at is the change in y over the change in x. So the change in x, that's not changing at all. 1, 1, 1, 1. Change in y is going up 2, then up 4, then up 8. So that is definitely not linear. So we can kind of cross out the two linear ones, and then we just can test out both of these. So 2 to the x power, so let's test out 1. 2 to the first power minus 5 to the first power, or times 1. So I'm just plugging in the x value, see what we get for the y. So 2 to the first power is 2, minus 5 is negative 3. And so since that is not what we're looking for, that's out, and we have an answer B. Now, if you want to test that out, we can test out letter B, so y equals 2 to the first power minus 6. So that's 2 minus 6, which is negative 4. That's what we're looking for. And if you did that with 2, 3, and 4, you would get the same thing. Okay? So, for the next one, in a recent survey, 75 juniors and seniors at Franklin Central, 66 of the students were in favor of hosting prom at an outside venue instead of hosting it at the school. So based on the survey results, approximately how many of the 1,520 juniors and seniors are in favor? So basically what you're doing here is the sample size you're using, 66 students, so we're in favor of outside of Franklin Central. That was 66 out of the total of 75 juniors and seniors, so that's 75 total. So based on that sample size, we can try and predict what it would be out of the actual total of 1,500. Okay, so we're trying to predict how many would say outside if we got everybody to say so. So 1,520, we don't know how many, so we just say X. So again, look at your units. Outside on top, total on bottom. Okay, and so let's go ahead and cross multiply. We got 75x equals 66 times 1520, which, use my calculator, 66 times 1520, 100, 320, 100, 320, and divide by 75, and what do we get? So to the nearest student, we're going to have that divided by 75 equals 1338, round up. 1338 students, okay? So once again, that is a proportion, okay? So number 11, the Steakhouse, a restaurant, opened a restaurant 32 weeks ago. The table above shows the number of customers C during the W week. Which of the following correctly explains the growth of C with respect to W? So, again, we want to check what's the change in Y over the change in X. So that's up 30 over 1, okay? So this one goes up 60. Change in Y over change in X is up 60 over 2, which reduces or simplifies to 30 over 1. And then this one goes up 120 and up 4 for the week, which reduces to 30 over 1. So you can kind of see the pattern here. Even though the weeks are going up by a certain amount, it's still the same change over the same change. So that is linear. So we can kind of get rid of the exponential one, C and D. And then look what's happening. The number of customers per week grew linearly because the number of customers per week increased by approximately 30 every week. So that is exactly what we were just looking at. So that would be A. And you can kind of see why that's the case and not this one. 100% every week wouldn't be the case because it says like after the first week that'd be 100% is 30, but then 100% would be 60 in 1 week. We went 100% in 2 weeks. Okay. So let's go ahead and look at number 12 here. It says a representative's sample of households in City A reveals that 14.8% of households in the sample have exactly 2 children under the age of 18. So 14% of people, of households. If City A has a total of 59,317, approximately how many of them have exactly 2 children under 18? So if that sample size is 14.8, we're going to assume the whole thing is 14.8. So all we're really doing here is taking that percent of the total. So 14.8% would be really 0.148 of, so times 59,317. And so when we multiply that out, let's go ahead and go 0.148 times, what was it? 59,317. 59,317 equals 8779 to the nearest household. 8779 households. And there we go. So you're taking that percent of the total. Okay. So let's look at those. The last one here. This is kind of taking you back to a little bit of middle school statistics, maybe. You've probably seen this before. So the table to the left shows the items Stevie bought from the garage sale and their prices. So list the prices from small to large. So the smallest one here is 3. Then we have, smallest one was 2. 2, then 3. Then we have 3 5s. 1, 2, 3. And then we have a 7 and a 15. So list the range. The range is when you take the highest minus the smallest. So our range is 13. Find the mean. Mean is when you take the average. So we need to add them up. So we've got 2 plus 3 is 5. 2 plus 3 is 5. Plus 5 is 10, 15, 20, 27, and then 42. So 42 divided by how many we have, which is 7, which gives us 6. And that would be our mean. Median is when we figure out what's in the middle. So 1, 2, 1, 2, 1, 1. So the middle or median would be 5. Okay, and then the mode just means what happens the most. So clearly the mode would be 5 since it happens 3 times. And there we go. That is 13. So on the next page, we're kind of doing the same thing. Number 14, we have the table to the left shows Jasmine and Pablo's practicing minutes. So find the range of Jasmine's practice times. So Jasmine, since it's the range, we just need the highest minus the smallest. So we had this highest was 60, smallest was 30. So her range was 30. Whereas Pablo, highest was 120, lowest was 0. So 120 would be his range. That's all there is to that one. Okay? So number 15, this is talking about taking data and what can be a good method of taking data. Okay? So a school district employs 2,000 teachers in its 40 elementary middle, and high schools. A high school teacher working in the district wants to figure out the job satisfaction and thinks it varies from school to school. So it wants to estimate the proportion of all teachers in the district who are satisfied with their job. So there's a few sampling methods to the right here. We got to figure out why these are flawed. What makes these not good sampling methods? So number one, let's look at number one here. Surveying 30 randomly selected teachers working at the school with the lowest funding. So far so good until the end, because it says working at the school with the lowest funding. We want to survey all the schools in the whole district, not just the school with the lowest funding. So let's see, it says sample is not random, D. So the sample only represents one of the 40 schools, so that doesn't work. That's why that's flawed. So the next one, number two, surveying 40 randomly selected high school teachers in the district. Well, what's wrong with this one? We're talking about elementary, middle, and high school, not just high school teachers. So we've got to go ahead and say that's flawed as well, because it doesn't represent the elementary and the middle school teachers. All right. Okay, so let's look at number three, surveying the 10 highest paid teachers. Well, that doesn't make any sense. That's not random at all. That's not random. That's specifically interviewing high paid teachers. Okay. And then the last one, number four, we've got surveying 50 randomly selected teachers from 50 different districts. We don't want different districts. We want to know about this district. So that'd be flawed in that way. Okay? So let's go to the next one here. Number 16, last one. A school district wants to conduct a sample survey to determine the average number of sports played by a high school seniors in the district. Which of the following survey methods is most likely to produce valid results? So we want to know how many seniors, the average sports of specifically seniors. So the district surveys every 10th student to enter a football stadium. Well, seniors are not the only students entering a football game, so that's wrong. The district surveys 500 randomly selected high school seniors in the district. That one seems okay, but let's see what else we have. The district surveys 500 randomly selected high school seniors in the district who play baseball. Well, we're not talking about baseball players only. We got to throw that one out. The district selects one high school in the district and surveys all its students. So again, we don't want to know about one high school. We want to know the whole district. So the final answer would be B. Okay. And so that's it. If you want to go ahead and pause and take a look at all the answers here, you can kind of take a screenshot. We went over all of the answer, but those are the answers for those. So if you have any questions, please ask. Please email me. And again, on Monday, we will be taking our test over this stuff. So it's about the same length, 16 questions or 15 questions or so, over problem solving, statistics, all that kind of stuff. Okay? So let me know if you have questions, and please email me. Peace.